of Physics. Module 1. Heat and Temperature. Heat is a form of energy called thermal energy. This energy is usually transferred from a hot object to a cooler object as a result of the temperature difference. Now let's look at temperature. Temperature is defined as the degree of hotness or coldness of an object. The higher the temperature, the hotter the object, and the cooler the temperature, the lower the temperature, the cooler the object. Now, the temperature of an object is measured with the aid of a thermometer. Either you want to measure it in degrees Celsius or Kelvin. Next, we look at the effect of heat. What does heat do to a body? Number one, it changes the temperature of the body. Secondly, it changes the state of the body, either from liquid to solid, or solid to liquid, or liquid to gas, or gas back into, depending on if I'm heating it or I'm cooling the body. Next is the expansion of the body. It can cause expansion, especially in metals, in glass, which causes it to fracture. This is what happens when hot water is put into a tumbler. It can actually crack because of the expansion process. Next is the change in the physical properties of the body, such as resistance, conductivity, density, or color. Next is a change in the chemical properties. Also, changes in the pressure when gases are heated. And also thermionic emission, which is the emission of electrons from the surface of a metal by the application of heat. Next, we look at the change in state or change in phase. Now, from the diagram, we can see that we have three phases: liquid, gas, and solid. When liquid changes into gas, we call it evaporation. And when gas returns back to liquid, we call it condensation. Likewise, when liquid changes into solid, we call the process freezing. And when solid returns back into liquid, we call the process melting. Also, when gases turns into solid, we call it deposition. And when solid changes to gas, we call the process sublimation. And the detail of the processes or the terms are given below. So fusion or melting, as we saw above, fusion or melting occurs when solid changes back into liquid, and the temperature at which that happens is called the melting point. Now, secondly, we have solidification or freezing. As we can see here, freezing occurs as liquid changes into solid. Also, vaporization. This is the process by which a substance changes from a liquid to a gaseous state when heat is applied to it, and that temperature is called the boiling point. Evaporation. This is the process where a liquid turns into vapor below its boiling point. Evaporation is slightly different from vaporization. Vaporization is called boiling, and that occurs at a specific temperature, but evaporation occurs at usually a wide range of temperature. Alright, please don't confuse them together. Boiling point is a specific temperature, but evaporation can occur over a wide range of temperature. Next, we have condensation, which is the process by which a gas or vapor turns into liquid. And sublimation, as we have described earlier, occurs in dry ice, camphor, and etc. And deposition also is the process by which gas changes into solid without passing through the liquid state. Now, let's look at the thermometer. Now, the thermometer is used to gauge the degree of hotness or coldness of an object, actually. And thermometers make use of a substance whose physical property change in a known way with temperature, and this is called a thermometric substance. And that's why it's usually easy to use devices, or let me say instrument, to measure temperature usually makes use of a substance whose physical property changes in a known way with temperature. And we look at the temperature scales. We look at the Celsius scale, Fahrenheit scale, and the absolute or Kelvin scale. Now, if you can see from the diagram, the first scale is the Fahrenheit scale. The Fahrenheit scale has an absolute zero of minus 459 degrees Fahrenheit. This is the theoretical lowest temperature that we believe we can achieve. That can be achieved. That's the absolute zero. But the lower fixed point is 32 degrees Fahrenheit, while the upper fixed point for the Fahrenheit scale is 212 degrees Fahrenheit. Now, for the Celsius scale, we have our absolute zero to be minus 273 degrees Celsius, our lower fixed point to be 0 degrees Celsius, and our upper fixed point is 100 degrees Celsius. And on the Kelvin scale, we have absolute zero at 0 Kelvin, our lower fixed point as 273 Kelvin, and our upper fixed point at 373 Kelvin. Now, note that the SI unit of temperature is Kelvin. Now, let's look into simple temperature conversions. Now, I want to convert from Celsius temperature to So sorry, from Celsius into Kelvin. Now I'm given a 45 degrees Celsius temperature to convert into Kelvin. Now the formula that does that conversion is temperature in Kelvin equals to temperature in Celsius plus 273, and then that gives me 318 Kelvin. Now from the diagram just beside, we have the Kelvin, we have the Celsius. Now let's check. For 45 degrees Celsius is in between 40 and 50, right? So therefore the answer we get for the equivalent Kelvin scale should also be between 313.15 and 323.15, which is very correct here, as I had 318 Kelvin. So that is very correct. Now let's look at temperature conversion from Celsius into Fahrenheit. Now, if I want to convert 50 degrees Celsius into Fahrenheit, the formula to use is temperature in Fahrenheit equals to 1.8 multiplied by the temperature given in Celsius plus 32. And in this question, the final answer is 122 degrees Fahrenheit. Now, let's just look at the diagram beside. Let's look at the 50 degree mark on the Celsius scale. You can see it's equivalent to 122 degree Fahrenheit on the Fahrenheit scale. So that is very correct. And lastly, we have also the third question that says convert from Fahrenheit to Celsius. Now if I want to convert 140 degrees Fahrenheit to Celsius, the formula applied is Tc equals to 10 open bracket degree temperature in Fahrenheit minus 32 over 18, which finally gives me temperature of what? 60 degrees Celsius. 60 degrees Celsius. So if I check my scale, 140 degrees on the Fahrenheit scale is equivalent to what? 60 degrees Celsius. And that settles that. Now, types of thermometer, we have the manometric, which works based on pressure, all right, of the gas, of the liquid. We also have liquid in glass thermometer, and that consists of a glass bulb and stem with a working liquid. The liquid could either be alcohol or mercury, okay, or inert gas, and when the temperature changes, the liquid expands or shrinks. Now let's look at the gas thermometer. This works based on the difference in pressure or volume of the gas in which we fill it with. Also, we have the bimetallic thermometer, which works with the bimetallic strip that is very sensitive to changes in temperature. As well as we have the digital thermometer, which has a thermistor that reacts to temperature change and also projects the temperature change on a screen. Now we also have the infrared. Infrared thermometer uses thermal radiation that objects emit to measure temperature. And this table also gives us a detailed view of the thermometric substance as well as the physical properties. And then this is the thermocouple diagram, which shows the odd junction and the junction at which the temperature is received, and the dial, the analog screen where the temperature reading is shown. Also, we have the industrial type bimetallic thermometer. And then also I want to give us a quick reminder here that some of us might have wondered that in our temperature conversions, why or how did we get the formulas we use. I'll refer you to videos that we have made that explains how to derive the formula we use for the different temperature conversions. And you can also check our TikTok page. You will see a lot of that, and we're expecting to post some of them on our YouTube page, so you can check that out for detailed videos on how the formulas were achieved. Okay, now so let's look at the summary of our work so far. We have been able to learn that heat is the energy that is transferred from a hot object to a cooler object as a result of their temperature difference. Number 2, we learned that temperature is the degree of hotness or coldness of an object. We also learned that thermometers are used to gauge accurately the exact degree of hotness of an object or a substance. 4, a thermometric substance is a substance whose physical property changes in a known way with temperature. 5, there are 3 types of temperature scales in currently use, which is the Celsius scale, Fahrenheit scale, absolute or Kelvin or thermodynamic scale. And finally, we have the types of thermometer, which includes liquid in glass thermometer, gas thermometer, resistance thermometer, and bimetallic thermometer. I would like to hear from you and also receive your questions. Thank you for listening.